let's look at an example here. So let's say that I have this system here. X squared plus y squared is equal to 100. Okay. Now what does that look like graphically? Well, if you have x squared and y squared plus each other, that's going to be a circle of radius 10, actually. If you kind of remember doing circles from a long time ago. This is actually a circle. I'll show you the graph in a second once we solve this out. And then this equation here, well, there's only powers of 1 on x and y, so this is going to be a line, okay? So I have a circle and a line, and I'm trying to figure out where do they touch, okay? What values of x and y do they touch at, okay? So, how we do this? We can still use the two methods that we talked about for linear systems. Substitution and elimination, okay? So on this one, I'm going to demonstrate substitution, okay? And I think it works a little bit better than elimination because x and y in this equation, there's not really an x squared that I can cancel out with this x squared down here, right? And so I think generally substitution would be what you would want to do here, okay? So, substitution, what are my steps? I'm going to solve one of the equations for one of the variables. And if I were to use this equation, I'm going to have squares in it, right? And so it's harder to solve. This equation is nice. So I'm going to solve that for one of the variables, okay? It doesn't really matter which one I use. Let's maybe just solve for y, okay? So step 1. Solve for a variable, okay? So I'm going to solve for a variable in here. I'm maybe going to do y. Okay, so I'm going to minus my 3x over. I get negative y is 10 minus 3x, just subtracting over that 3x. And then to get y alone, I'll just times by a negative, or divide by a negative if you prefer. That will just switch both of those signs. Okay, so I now have an equation for y. Okay, I've completed step 1, I've solved for one of the variables. Then what I'm going to do, step 2 was to plug in that equation into the other equation. Or to just simplify that down, I'm just going to substitute. Okay? I'm just going to substitute in this equation here for y in the other equation. So I've got x squared plus negative 10, negative 10 plus 3x squared, okay? So this is x squared plus y squared, right? But y is this, so I just plug that in for y is equal to 100, okay? So now I have an equation with one variable, right? So I can solve for that variable. That leads us to our last step here. Step 3, solve for the variable. Okay. So let's go ahead and solve this. How am I going to do that? Well, I have a square here over this whole thing, so I should distribute this out, okay? So I'm going to have still an x squared here, and then I'm going to have, for the square part, let's say negative 10 plus 3x, and times a negative 10 plus 3x, right? That's the same thing as squaring it, you're just timesing by itself. So then we can FOIL this out, or Santa hat if you prefer. We would get x squared plus negative 10 times negative 10 is 100. So we've done those two. Then negative 10 times positive 3 is negative 30x. So that's there, okay? And then 3x times negative 10 is negative 30x. And then 3x times 3x is 9x squared, and this all equals 100. Okay? So I'm just multiplying this out so that I can get an equation to solve for x. Okay? So, now what do I do here? Well, we can simplify things a little bit, right? I have a x squared and a 9x squared, so that's going to give me 10x squared. Okay. I've got a two negative 30x's, so that's negative 60x's. Okay. And then I've got this plus 100 on this side. Okay, just combining up like things, this should equal 100. Okay. So I'm just combining up like terms on this side of the equation. Get this. So now what? This is a quadratic equation, but it's not equal to 0. So I'm going to subtract the 100 over so that I get it equal to 0. And I get 10x squared minus 60x. This is equal to 0, right? The 100s cancel out. Okay. And so now I just want to figure out what x's will give me 0 here, which I can factor this, right? Is there anything that goes into both of these? Well, a 10 goes into both, and there's an x in both. So let's take out a 10x. On this first part, I'm left with an x. And then something times 10x to give me 60x, I need 6. Okay? Is equal to 0. So what values of x will make this work? It would just be, well, where will this be 0? It will be at x equals 0 and x equals 6. Okay. So those are my two values for which this could work. Okay. So this is one part of our problem, right? But remember, when we find x, we're not quite done yet, right? We still have to find y. So that's our final step. So we're gonna, well, I think the book calls this back substituting, right? Okay, so I'm gonna back substitute. I'm gonna take these x's and I'm gonna find out what y is. So the equation that I should use is the one that's solved for y, right? So I plug in, let's see, what was our equation? I'll write it right here. Y is equal to negative 10 plus 3x, okay? So that was our equation that we solved for y. So now I just plug in those two x values to get y. So when x equals 0, what do I get? Y would equal -10 plus 3 times 0, right? Just plugging it in for x. So y would be -10. Okay? When I plug x equals 6 into this equation, I would get y is -10 plus 3 times 6. Okay? 3 times 6 is 18. So we get -10 plus 18, y would be 8. Okay? So I have two answers, right? One is -10 and one is 8 for y. This one corresponds to 0, this one corresponds to 6. So my final answer is just 0, -10, that's 1 point, and the other point is 6, 8. Those are my answers. Okay? So you'll notice the process is very similar. It just can be a little bit longer because you can have multiple points where it intersects. Okay? So let's just review our steps again. For substitution, step 1, we solve for one of the variables. Step 2, we substitute it into the other equation. Step 3, we solve for the variable that we have, which will usually involve you having to distribute something out. Then we back substitute in to get our final answer, what the other variable should be. Okay? So, hopefully that's helpful. I'll show you a graph of the situation, right? Remember this x squared plus y squared equals 100. This is a circle of radius 10. And then this other line that we have, 3x minus y equals 10, it's a line that looks like this. You'll notice they touch each other at 6, 8, which is what I got, and 0, -10. Okay? So this is right. What we did actually did tell us where these two things intersect. Okay? Which is pretty cool. We take a complex problem and we're able to solve it just algebraically by messing around with these equations. Okay?